Good morning, everyone! I am a Mary Rose Briones, Grade 10 Mathematics teacher. Today, I will discuss the Week 8 of 3rd quarter. At the end of the session, you will be able to identify mutually exclusive event and not mutually exclusive event. Find the probabilities of mutually and not mutually exclusive event. And value accumulated knowledge as means of understanding. Now, let's have fast talk. Choose between the two. Which road you will take? Left or the right? Which coffee you prepare? Hot or cold? Sleep with lights off or lights on? Indoor game or outdoor games? What do you want to vote? For male or female for president? What do you like to play? Mobile Legends or Call of Duty? And which modality you prefer? Online or modular? Okay, all your answer is correct because it's your own opinion. But let's analyze. What do you observe about the activity? Yes, there is always two options. Was it easy for you to decide what event to choose? Some might say yes. Some might say no. So it depends on the question. Is it possible to choose both? The answer is no. Because it cannot happen at the same time. So, what do you call an event that cannot happen at the same time? In mathematics, particular probability, that is what we call the mutually exclusive event. How about the event that can happen at the same time? That is what we call the not mutually exclusive event.
Mutually exclusive event. Mutually exclusive event if A and B are events which do not have any common outcome. The probability that A or B will happen is given by probability of A union B is equal to probability of A plus probability of B. In Venn diagram, this is how it looks like. Two events A and B cannot occur on the same time. While in not mutually exclusive event A and B are events which share at least one common outcome. The probability that A or B will happen is given by probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. In Venn diagram, this is how it looks like. Two events A and B can occur on the same time. Let's have this example. Example number 1. Mario has 45 red chips, 12 blue chips, and 24 green chips. What is the probability that Mario randomly selects a red or a green? So we have 45 red chips, 12 blue chips, and 24 green chips. Since they don't have common outcome, this is mutually exclusive event. To get the probability in selecting red or green, we will add the probability of A plus the probability of B. The probability of selecting red is 45 over 81 and the probability of selecting green is 24 over 81. So the probability of selecting red or green is 69 over 81 Or simplifying it, we have 23 over 27. Example number 2. A card is drawn at a random from deck of 52 playing cards. Find the probability that the card drawn is an ace or a king. It is mutually exclusive event since they don't have any common outcome. To get the probability that the card drawn is an ace or a king, we will add the probability of A plus the probability of B. The probability of getting an ace is 4 over 52 since we have 4 ace and we have total of 52 cards in a deck of cards. The probability of getting a king is 4 over 52. We have 4 king and we have total of 52 cards in a deck of cards. So the probability of selecting an ace or a king is 8 over 52, or simplifying it, we have 2 over 13. Sample number 3. 15 balls in a jar numbered from 1 to 15. A ball is drawn at random. Find the probability that the number on the ball is less than 6 or divisible by 3. So we have set A and set B. For set A, a number less than 6 are 1, 2, 3, 4, and 5. And for set B, the number divisible by 3 are 3, 6, 9, 12, and 15. They have the common outcome, which is 3. Therefore, it is not mutually exclusive event since they have the common outcome. To get the probability that number on the ball is less than 6 or divisible by 3, we will add the probability of A plus probability of B, subtract to the intersection of A and B. The probability of number less than 6 is 5 over 15, since there are 5 less than 6. The probability that a number divisible by 3 is 5 over 15, since there are 5 numbers divisible by 3. And the common outcome, which is 3, thus giving the probability of A intersection B is 1 over 15. So the probability that a number is less than 6 and divisible by 3 is 9 over 15. Or simplifying it, give us 3 over 5. Example number 4. A card is drawn at random from deck of 52 playing cards. Find the probability that the card drawn is a king or a diamond. So this is not mutually exclusive event. Since there is a king of diamond, they have the common outcome. To get the probability that the card drawn is a king or diamond, we will add the probability of king to the probability of diamond and subtract it in the intersection of king and diamond, or their common outcome. The probability that the card drawn is a king is 4 over 52. And the probability that the card drawn is diamond is 13 over 52. And their intersection, or the probability of their common outcome, is 1 over 52, since there is only one diamond king. So the probability that the card drawn is king or diamond is 16 over 52, or simplifying it, it is 4 over 13. We are ready. Let's answer this. Tell whether mutually exclusive event or not mutually exclusive event. A card is drawn from a deck of cards. Event 1, Event 2, Event 3, Event 4, and Event 5 are defined as follows. For event 1, getting an 8. For event 2, getting a king. For event 3, getting a face card. Event 4, getting an ace. And event 5, getting an heart. Let's have number 1. Are event 1 and event 2 mutually exclusive or not? It is mutually exclusive event. Number 2. Are event 2 and event 3 mutually exclusive event or not? This is not mutually exclusive event. Number 3. Are event 3 and event 4 mutually exclusive event or not? This is mutually exclusive event. Number 4. Are event 4 and 5 mutually exclusive event or not? This is not mutually exclusive event. And for number 5, are event 5 and event 1 mutually exclusive or not? This is not mutually exclusive event. I hope you are all correct.
That's all for today. Thank you and God bless.